Alright, another series of videos about pulleys. So, first one, some basics. Object on table. And then one, another, and freehang. Okay, so table, pulley, thing, like that. Number two, two objects, hanging, freehang. We got our pulley, rope around, two objects hanging. Then we'll do object on inclined plane and one hanging. So inclined plane, object, rope, tension, pulley, freehang, ground. Okay. Then we'll do one like this, but with friction. Force of friction. Okay. Then we can bring friction into these. No friction, friction, no friction, friction, no friction, friction. So we'll go through that process in some different videos. One video about each series. All right, so let's do this. The first thing. Object on the table, one's hanging. So here in this beautiful diagram, legs will need to be a little longer. Ground. Okay. To do this, we need Newton's laws and pre-body diagrams. So, tools. Among others. Newton's laws, pre-body diagrams, pre-body diagrams, Newton's laws. Now, one thing, so some strands will come up in all we do, and in doing these videos, these four, with free body diagrams and stuff, it will help to draw them and think about direction. So remember on the x-axis, if we've got a number line, to the right we have positive, to the left we have negative. That idea we'll use here. It'll help us keep things straight, know what's going on. Then we got to look at our forces. So here, instead of this situation, things are different directions. What's going on? Think about, remember the tension connects them. It couples them to each other. One object to the other. A force is transmitted through the rope or whatever. And we're pretending the friction has the pulley has no friction. We're ignoring friction here. So box, string, box. And then think about this to help us decide what goes here. So we draw this to help us identify what's important in the real world that we're going to use. Then we use this. This doesn't help unless we know about the real world and there's gravity and it's pulling something down. So here we're going to have to the right is positive, to the left is negative. So on this one, if it's going down, that'd be this way. Down, when we pull it up, it'd be like that. Tension's pulling up, so it's this way. So we got force of gravity, the weight, and then we got tension. But notice here, tension's the opposite direction. So this will be a negative, and this will be a positive. And then nothing going the other way, right? The up and down we don't care about, because this is connected sideways. If friction would come into play, then we'd need the normal force to like transition and stuff, but that's what we got. So we have our free body diagram. We got that. Now, Newton's laws. If we call this like M sub 1 or capital M, one mass, the second mass, M sub 1, M sub 2, then remember second law, the total force is MA. So here, what's the total force? Tension. So T is M1A. And then here, we got FG to the right minus T is M sub 2A. Okay. And you know this is in our text. But they use like capital M and small m. Different version of the same thing. So then tension is M1A, so we can substitute that in. We can think of it that way. You could get this and put it down here and add the equations together. That's one way to think about it. Like T equals M1A. Then we add, and F sub G equals M1A plus M2A. Or we can think about it as we get this and substitute in if G minus M1A is M2A. Then we add M sub 1A to each side, and we get that. Then you get the acceleration, factor out the A. So we have to know how to do literal equations. Okay. And then divide by M sub 1 plus M sub 2 to solve for A. And we end up with, I'll put it over here. Then I can do some problems down here later. A is force of gravity, M1 plus M2. Because we divide, just in case someone needs it, we're dividing by this whole thing. Squeeze the writing in down here. Not much room. Move my hand. Okay, so we get that. But F sub G is here with M2. So put in M sub 2G for this. So okay, and that'd be our acceleration. Then we got to like know if it's going left or right. So we got T to the right, tension's pulling, T pulling this way, S sub G that way. and M1, M2. And so notice for one thing, okay, we'll go with that later. Look at that. Acceleration, this, put it in, add it to both sides, factor out, divide. Okay, now, if we think about it, whoops, computer screen went dark. So, there. Now, we can think, does this make sense? Did we do it right? I mean, we did, you know, but think through things more, please. Look at the evidence. See how this integrates to other things you know. So what about, look at like the weights here to make a little sense of the formula. If m sub 1 was 0, it goes away, then we have m2 divided by m2, which is 1, and acceleration is the force of gravity. If there's nothing here, it's just acceleration due to gravity. That's what's pulling on this. It's like in free fall. The rope might, you know, would be insignificant in that context. Or if m1 is really big compared to m2, maybe m2 is like 0.0000001 kilograms. That's a small fraction. 0.00001 over 1. I'm going to run out of room. So stop at 100,000. This over this becomes insignificant, because remember, with a fraction, as b gets larger and larger, this goes to 0. So notice 1 over 10, 1 over 100, 1 over 10,000. So when the bottom number gets bigger, the fraction gets smaller. We have less stuff, it goes to 0. So what would the acceleration be when this is really, really big and this is really, really small? Nothing. You go to 0. Okay? The more this is, the less this will accelerate. And of course, then remember, this is like frictionless. Ignoring friction for now in the pulley and on the table. When there's friction, then of course, no acceleration even earlier than the non-friction case, where the acceleration will be really, 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 really small. Okay, so that's what's going on here. That helps us understand the formula. Remember, if m1 is 0, then this is like in free fall. If m1 is really big compared to this, then acceleration is negligible. So it makes sense. So then if we do a problem or two with this, okay, that's how we derive our acceleration. Then, you know, we could like plug it in to get the tension, because acceleration is that, tension is this. We put this in place of A, and so tension is m1 times m2 over m1 plus m2 times g. Or you can put it in here and get a formula, but this would be more efficient. Okay, and then I'll erase this and move this one over there. So I'll put this up here. T, then we'll do a problem. M1, M2, M1 plus M2, G, or M1 times M2. Acceleration, M2 over M1 plus M2, G, where 2 is hanging and 1 is on the table. We can't get them switched out because that's how we did our analysis. Our analysis is M2 is here, and M1 is at first and second. Okay, so some problems. Now, if we have this one, like number 1, I'm going to do on a worksheet. I'll put a link in the description field. Number 1 on the right. 2 blocks are joined as in the diagram below left. The mass of block A is 8 kilograms. So we have a situation like this, where A is here, our M1. We'll say M1 just to make it consistent with what we're doing. They call it A. M2. Or they're in the wrong place. M sub 2, and that's what they're calling B on the worksheet. So M sub 1, M sub 2. M sub 1 is 8 kilograms. M sub 2, 2 kilograms. If block A is on a frictionless surface, calculate its acceleration. So we shall do so. The power of abstractions allows us to do this. This is the generalization which applies to this situation. Everything like this has this kind of acceleration. So we got this, we did the math, we generalized, and we got this. Just like all dogs bark, you know, within a certain context, as long as their vocal cords are working and stuff, you know. All situations like this have an acceleration given by this formula. So we apply it. Then we got our 8 and our 2, then acceleration 2 over 2 plus 8 times 9.8. 2 over 2 plus 8, 2 over 10. 2 over 10 is 1/5. 1/5 is 0.2. And then we got 0.2 times 9.8. And we see 0.2 times 9.8 equals 1.96. So 1.96 meters per second squared. You can round it to sig figs. Cool. Then we can get the tension. Do M1 times this, and it's the tension in the rope. All right. So then we can do other stuff. Like let's say we have mass 1 is 8 kilograms. Mass 2 is unknown. Acceleration 3 meters per second squared. We should be able to like work our way around in this and do different things. Use the formula different ways. So we got the situation. We use our formula, and so 3 equals x over 8 plus x times 9.8. Okay. And then solve that. So we could do, put the 9.8 on top. We can make it Okay, looks like 9.8 over 1. 9.8 times x, 1 times this. Some people do weird things when I multiply this by the top and bottom. But if you do that, it's like multiplying by 1. If you got 3 over 5, you multiply by 2 over 2. That's 6 over 10, which is 3 over 5, because 2 over 2 is 1. So please do not multiply the top and bottom by the same thing when you're supposed to be multiplying by 2. Oh, don't go to sleep. Okay. 3 over 5 times 2 is like 2 over 1. And that's 6 fifths. If we double 3 fifths, 3 fifths is 3 of 5 equal parts. 1, 2, 3, 4, 5. If we have 3, 1, 2, 3, 4, or 6. Wrong. So 2, 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. There's 1, 2, 3. If we have 3, and pretend they're equal. I just do it really quick. You get the idea. 3 of 5 equal parts. If we double that, we're going to have 6 of them. 2 times 3 fifths is 6 fifths. 3 of something, 2 times 3 is 6. So, likewise, if we multiply by 9.8, multiply the top only, please. Now we cross multiply, bottom times top, bottom times top. Then distribute subtract 3x. Then divide by 6.8. So 8 divided by 6.8. 1.1, call it 1.2, round off. I don't know, 1.18 kilograms. Okay. And make up some of your own problems and think through what it would be. So we were given masses in the first problem and found acceleration. What if we're given a mass and an acceleration? We got to find the mass. What if we're given 2 masses and an acceleration? We need to find acceleration due to gravity. We're on a certain planet. We do this. We see what the acceleration is. We can get the acceleration due to gravity. Okay, work our way around and stuff like that. So, first video. This one's long enough. So then I'll do friction with this in another one.